Welcome back to another video. In this tutorial, we are going to look at how we can understand the concepts of logarithm. Okay, so basically, if you want to understand mathematics very well, one of the key topics or one of the key aspects that you have to give a mastery is logarithm, and indices, one of the key aspects, and as well real number system. So this is what we have. We want to understand logarithm. Okay, so first we have to know the basics of logarithm, right? So you know that by symmetry, a is equal to a exponent, right? A exponent 1, right? And that is by the law of symmetry. By the law of symmetry, that is obtained from real number system. That is okay. That is a basic logic, right? So this is a basic logic. Let's move on. So we have a equals a exponent 1. That is symmetry. Now we know that log a subscript a, log a base a is equal to 1. That is another basic thing that you have to know in logarithm. Once the base and the log is the same, you're going to have an answer to be 1. That is why we always say that log 10 base 10 is equal to 1. Is that right? Good. So once again, if you have log 10 without any base, that means the base is at default. And at default, we have base 10. At default, the base is 10. Okay, so we know that. Now the next basic log property, or that is not even property, that is the basic thing you have to know about logarithm, and that is what I'm basically talking about over here. So let's look at some problem. Okay, so this is what we have. This problem, I have this problem here. For instance, you have log of log 8 base 2, right? How do we do this? What can we do? So here, okay, let's make it base half. Okay, so we want to find this log. Okay, so the best thing we have to do is to equate this to x, right? So our normal way of working things out, this here we can say that the 2 here, the 1/2, which is the base, will go and carry the value over here. So we have half exponent x, and that is equal to 8. So that is how we solve this kind of problem. So whichever problem that you have and it's of this format, just equate it to a variable and solve for x. Okay, so this is what we're going to have. So we have half or exponent x equals 8, right? We know that half can be expressed as 2 exponent negative 1. That is okay. That is a basic logic. So we have that is equal to 8 over here can be expressed as 2 exponent 3. So because of the bases are the same, then we can say that 2 exponent negative x equals 2 exponent 3. Since the bases are equal, we can equate the exponent, and that is going to be negative x equals 3. So we can say that our x equals negative 3. That is interesting. So that is what we have here. Okay, so that is how we go about this kind of problem. Now we've been able to solve this. So the next thing is I want us to know some fundamental properties or some fundamental okay, let me term it a property. Okay, so some fundamental properties of logarithm. Okay, so we know that first property, so that is some fundamental properties of log. right? So that is some fundamental properties of logarithm. So we know that if you have logarithm, right? Should I continue or you continue for me? You know that if you have a log, okay, and they are multiplying, it means they are adding, right? The log says that you can add them, and if they are adding, then you can multiply them. So it's vice versa. Okay, so for instance, you have log AB base, let's say A. Okay, so if you have log AB, first property, log AB, right, base say A, right? Then the law says that this is equal to log A base A plus log B base A, right? Since they are multiplying, you add them. You split the terms over here. So that is basically we have here. So this we can have log AB base A is equal to, from what we did here, log A base A is absolutely 1 plus log B base A. So this is what we have. This is what we have. And that is so interesting. So interesting. So this is what you have here. Wow. Anyway, you can like we can make this base to be C so that we don't have any breakdown. But all the same, that is the property. If they are multiplying, it means you can split them and make the sign between them become positive. Okay, 2, property 2 or property B. If you have log A over B, log A over B, right? So the log function is A over B, base C. Then you can subtract them. If they are dividing, then you can subtract. So here you can have log A base C minus log B base C. So that is how you handle problems. That if the log is dividing, you subtract. That is the property. That is a fundamental property. And if they are multiplying, you add them. Good. Now let's look at the third property, of which that property is the exponent property, right? So for instance, if you have let's say what example, okay, n log a log b base a, okay, then the property says that this can be written as log b or exponent n base a. If you have n log b base a, then you can take what is behind the log to go and have an exponent for the function in the log. Okay, so that is why we have the a moving to the exponent of what? B. So that is why we have log b exponent n base a. So that is the third property as well. Then the fourth property is when we talk about the change of base. Okay, so with that property, that is when we have, okay, so we can have that here. So basically, these are the properties. And if you have these properties at your fingertips, the rest is algebraic or algebraic work. Okay, so let's look at some problems that we can have under logarithm. Let's look at some problems. So let's clarify the concept of logarithm. Okay, so over here, this means that we have to change the base 9 to base 3. So changing from base 9 to 3. right? So we're going to have applying the logarithm property, the change of base property, then this is going to be log y base 3 over log 9 base 3, and that is equal to 6, right? So over here, we're going to have log y base 3 plus log y base 3 all over log 3 squared over base 3. 9 can be expressed as 3 squared. So we have log y base 3 plus log y base 3 over 2 log 3 base 3, right? And that is equal to 6. Good. So over here, we're going to have log y base 3 plus log y base 3 all over 2 log 3 base 3, and that is equal to 6. Okay, so this we're going to have log y plus log y base 3 plus log y base 3 all over 2 into 1, and that is equal to 6. We know that this is basically 1, right? Log to the same base is equal to 1, right? And when log y base 3 plus log y over log y base 3 over 2, and that is equal to 6, right? So over here, we know that we can spread these two across all the terms. So we're going to have 2 log y base 3 plus log y base 3 equals 12, right? So here we applied the change of base property, and then we applied the exponential property, and then finally we are coming to apply the addition property, which says that if they are adding, then you can multiply the terms, right? So here, let's apply the exponent property right here. So we're going to have this go and carry this. We have y cubed base 3 plus log y base 3 equals 12, right? So this, they are adding, so you can multiply. You can take one of the log, since they are all the same base. Take one of the log, then you multiply the function. So you have log y, you have log y squared times y base 3 equals 12, right? So over here, you're going to have log y exponent 3 base 3 equals 12, right? So we know that this is basically log base 3 y exponent 3 equals 12. So from the beginning, we know that this will go and carry the what we have here, and that is going to be, so once it carries the 12, then the log will go away. So we're going to have y power 3 equals 3 exponent 12, right? So this is equal to 3 exponent 12 is 5 3 5 3 1 4 4 1, and that is what we have here. So now we need y. So taking square root, cube roots on both sides, we're going to have our y to be 81, right? So that's the value of y is equal to 81. So interesting. Ladies and gentlemen, I really appreciate your time. Don't forget to subscribe, share with your mates, and I'm going to give you more